Hello and welcome to Chemistry in the Community. We are starting off our chemistry journey. What better place to start than to take a look at safety and precautions that we should be thinking about when we enter the lab space. So today is Safety 1.1. You have a worksheet there that you can follow along and fill in the blanks with the notes. Typically with my notes, the blanks will be in red on the PowerPoint, and you can kind of follow along. And if you have any questions as you work through, just write them off to the side and you can ask me at a later time or through email. In chemistry class, you should only ever follow the procedure. You should never kind of make your own experiment in lab. And you might think to yourself, well, I thought, science is about experimenting and, trying new things. It is, as long as you have enough background knowledge to basically do those procedures safely. You are a novice in chemistry at this point, more than likely, and because of that, you should not be taking two chemicals that you are not familiar with and dumping them together to see what would happen. Sometimes chemicals can produce gases that are dangerous. Sometimes they can produce solutions that are dangerous. So we just want to make sure that we're always following the procedures. If you have any medical problems, if you have allergies or asthma, or yes, if you're pregnant, I need to know those things because there could be certain chemicals that we work with that could cause your allergies to react, or it might not be safe for you to be around if you were pregnant. Never eat and drink in the lab. Don't even take it back there. Even if you're just like, well, it's just water. You cannot take your water bottle into the lab. Anytime you're working with chemicals in the lab setting, you should never be eating or drinking because of cross-contamination. Along with that, keep your work area clean. Don't be dragging your book bag back there or all this other stuff to the lab area. We want as many clean surfaces as possible. You're going to need your lab, and you're going to need something to write with. That's what you should take. Sometimes you'll need a calculator. That would be okay. On lab days, we don't want to wear any loose sleeves or jackets that if you were reaching across the lab bench, you might accidentally catch on fire if we're using a Bunsen burner. Same thing with jewelry that's hanging down. If you lean over, that could create a problem. Hair is also an issue. We want to tie back loose hair if you have long hair, or even just push it behind your shoulders to make sure that when you're leaning over, it's not falling into a solution or getting near a Bunsen burner. Another safety wardrobe issue would be to make sure as best you can to wear closed-toed shoes. This will help so that if you spill on the floor that you don't get any chemicals on your feet that were open and exposed to the air. This is one of the biggest rules, and it's one of the things that you'll probably get irritated with the most, is you must wear goggles at all times. If you are in lab, you are wearing goggles. I do not care if we were doing an experiment with water and salt. If you're in a lab situation, you will wear goggles. All right? No horseplay. This would be an immediate dismissal from lab. Keep chemicals and paper away from open flames. If we're using the Bunsen burner, don't get your lab too close. And don't put your eyes, face, mouth near the opening of a chemical container. We never want to look inside something or bring it up to our mouth to smell it or nose to smell it. We're constantly being cautious. Usually what I say is everything is hot, everything is dangerous. If you work with the premise that everything is hot and everything is dangerous, it will help you with the mindset of caution as we kind of proceed through this. Some types of experiments will have things called noxious vapors, which will produce things that smell very strong and could potentially even knock you out. And we would do those in the fume hood. It's basically a giant exhaust fan, and it pulls all the vapors out and blows them to the outside. In class, I will demonstrate this for you, and you can kind of see how this works. There's other emergency equipment that you should be aware of in lab. There's first aid kits in my room and the lab. There's an eye wash station in the lab that I will show you and show you how it works. There are fire extinguishers in my room and in the lab. And finally, there's a chemical shower in the lab. It is not a toy. There's a lever there. You're really going to want to it feels like, oh, somebody needs to pull that. Do not. Okay. But we will demonstrate those things for you so you can kind of get a look at them. Waste materials. We do not just throw everything in the garbage. There are certain things that we put in the garbage and there's certain things that we don't, and there's some things we can wash down the sink. If it is glass, we have a special bucket for glass. You will probably break glass at some point this year, all right? And it's okay, but we put it in a special bucket so that it doesn't basically create a situation where it could cut somebody changing out the trash bag. If I tell you that solid waste can go in the trash can, put it in the trash can. There are certain substances that we will dissolve into solution that they can go down the sink. There are other substances that can't, and I'll usually have a waste container and say, make sure you put your waste in here. All right, so be aware of those different types of trash and where they go. If you spill a chemical, do not just run away from the spill to come get me. We need to make sure that people aren't walking through the chemical spill and creating a problem. So at least you or someone, your lab partner, stay with the spill, then come get me. Okay, hopefully it doesn't look like anything like this picture where we have radioactive waste in the lab. We will not. But make sure you're protecting the area so that people aren't walking through the spill. When you're handling chemicals, you should always double check labels. There are some chemicals we use that look very similar to one another, and if you're not careful, you are going to misread a label and use the wrong chemical. Always look for the formula. We don't want to take more chemical than we need. We want to make sure that we just take the amount we're going to need for the experiment. If you do have extra, you should try to give it to another lab group that hasn't gotten theirs yet. We do not put that chemical back in the source, because if there would be contaminants in your sample that you poured, now you're contaminating the source of the chemical that basically I've prepared for the classroom. So we never ever put leftover chemical back into a source container because of contamination. We are never going to mix chemicals together unless I instruct you to. The only thing you would ever mix together would be water, and that'd be to dilute something or to create a solution of something. I typically am the one who makes the acid solutions, and when you do that, you always pour the acid into the water. You never pour water in the acid, and the reason is because what you're pouring into, that's typically the thing that does the splashing. So if you pour water into acid and the acid splashes, now you have a very concentrated acid splashing potentially on your hand or on the counter. All right, but if you take acid and pour it into water and the water splashes, you're okay because it's just water. Always pour acid into water when diluting an acid, which is typically something that I will do in class. There are certain types of chemicals that have specific hazards. An allergen is probably the one you're most familiar with. You've probably heard carcinogen quite a bit too. An allergen just is something that inflames allergies. A carcinogen is going to be something that can cause cancer if you're exposed to it over a long period of time. We have mutagens, things that can mutate a gene or mutate DNA. And then the one you're probably not as familiar with is a teratogen. We won't use those in class, but it's something that can cause birth defects. So when you're working in a chemical lab, you need to make sure that the things you're around are okay based on your current health situation. When you handle glassware, as I said earlier, assume everything is hot. I can tell you story after story of students who've walked into a lab setting and they pick something up because they assume, like, well, this has been sitting here for 24 hours and there's no way this is hot, but it just came off a hot plate or it just came off a Bunsen burner. You have to assume that the class before you was in that lab space and was heating things or was putting chemicals in that thing, all right, in that beaker. So make sure you're always handling it with some type of care or caution, with tongs or a hot pad, okay, or a glove. If you would break glass, you want to make sure you let it cool down first, and then you're going to clean it up with the dustpan and put it in the glass recycle. The only type of glassware we heat is called Pyrex. You probably have baking dishes that are made out of Pyrex. It's typically just glass that has been tempered in a way that it can be heated and cooled without expanding too quickly and therefore shattering. When we clean glassware, we are first going to dispose of the chemical. We're going to clean with a paper towel and tap water. We're going to rinse with tap water, and then we're probably going to rinse with distilled and dry it. When you are in this lab, when you're done with something, don't assume because you rinsed it out with tap water that it's clean. Everything needs to be cleaned and dried. You might need to use a test tube or a beaker brush, which can be seen down here in the bottom right corner. Make sure that that stuff is clean so that the next period can come in and know that there's not going to be contamination in their experiment. When you are heating substances, you should always turn off a burner when it's not in use. You should never just be like, let's light the burner even though we're not going to need it till the second half of the class period. It heats up the room, it wastes fuel, and there's chances that if you don't have it set correctly, there could be an invisible flame or a flame that's in basically the tube of the Bunsen burner, and you'll think, that it's not on. So we need to make sure that we keep those off until the moment that we need them. We never want to look into a container that's being heated. When things get heated, they expand, and therefore we don't want to stick our eye and see what's happening from the top. We always look through the glass. In the same way, we're never going to put a rubber stopper in a container and then heat it, because things expand when they're heated, and that could cause an explosion of an Erlenmeyer or a test tube. If there's ever an injury, if you ever get a little burn on your hand or something, tell me about it, okay? Don't feel embarrassed. Don't feel like, I'm going to get in trouble. I need to know these things. A lot of times kids will break glass, or they'll get a little burn maybe on their finger from the Bunsen burner because they did something not so smart, and they don't want to tell me because they feel embarrassed. Just let me know so we can take a look at it, see if we need to send you to the nurse. It's okay. Things like this happen, but not very often. It's just we need to make sure we're doing everything we can to keep you guys safe. First aid. I'll show you where the first aid kit is when we're in lab. If you have an acid or base spill on you, if it's on your hands, we just rinse that off. Okay. Think of acids and bases. Concentration is king. All right. If you want to make an acid weaker, you're just going to dilute it, just like lemonade, right? You just add more water and it's not as strong. So if you would get a concentrated acid on your arm, we would just run water over it to basically water down the acid or base and make it less potent. Now, the only time you'd use the chemical shower is if you got it on your torso in a situation where you could not lay under a sink, okay? And that's when we'd use the chemical shower. That is what it is for. If you get chemicals in your eye, we would flush that eye and the eye wash for 15 minutes. That is a long time. But once again, we're just trying to dilute it as much as possible to water it down and make sure it's completely out of there. If you would ever ingest something accidentally, we are not going to drink or eat anything to kind of wash it out of your mouth, because in certain situations that could make it worse. We would always contact poison control, and we would kind of follow their procedure. Once again, this would be an extreme situation. The things we deal with on a regular basis are not typically dangerous or would not harm you in any way. If your clothing is on fire, do not flail. Do not do this, because it's going to feed the fire with oxygen. You need to smother the flames. You can stop, drop, and roll, or we have fire blankets that you could smother it with, but smothering is how you're going to get flames to go away. Same thing with fumes and noxious vapors. We don't want to smell them. We always want to use the wafting motion, where we kind of pull a small concentration of the fumes towards you, so you can maybe observe a distinct smell. But we never want to put the test tube or Erlenmeyer up to our mouth or nose area and get a strong concentration of those fumes. If a person is ever in shock, they would have wide eyes and they would not be showing emotion. And you would want to make sure we get them in a chair instead of walking them around, okay? Because they're not really with it. So always sit someone down, come get me, and we'll go from there. In this second half of the presentation, we're going to talk about MSDA and NFPA. These are two organizations that basically give health and safety measures for different types of chemicals and different types of equipment. You've seen NFPA Fire Diamonds probably before on maybe a propane container or something like that. We're just going to walk through them so you are familiar with what they are. NFPA stands for National Fire Protection Association. It is a graphic. It's a fire diamond, and that diamond has 4 quadrants. It has the top one, which is red, the left one, which is blue, the right one, which is yellow, and then the bottom one, which is white, and it can have Lots of different things in the bottom, all right? But the top three typically just have a number. So the top hazard is a fire hazard. And 4 is, for all three of these, the red, the yellow, and the blue, 4 is the highest hazard, or the most dangerous. So with a fire hazard, a 4 would be a flash point below 73 degrees, meaning that that chemical will spontaneously combust at room temperature. All right, so very dangerous. Yellow is reactivity, and a 4 would be it may detonate. So anything that would be very dangerous in terms of reactivity would react with the air. And then blue, a 4 health hazard blue is health hazard, and a 4 would be deadly, meaning that if it was ingested or if you were around it, that you could be in a lot of danger. And then down here at the bottom, we have what we call special hazards. It could be don't combine with water, it could be that it's an acid, it could be that it's a base, or that it's corrosive. Lots of different things we could put there. So what type of substances would be a 4 on the fire rating? Pyrophoric substances would be spontaneously ignite in air, white phosphorus, plutonium, uranium, the alkali metals, which you'll actually see this year. Those are the kind of things that would literally burn with the oxygen in the air. They would not need any kind of like match to get them started. They just ignite. What would be reactivity of 4? Nitroglycerin, which we make TNT out of, chlorine dioxide, things that just, if you drop them, they could literally explode. Health concerns, that would be a 4, that would cause imminent death. Hydrogen cyanide or carbon monoxide, mustard gas. There's all kinds of different chemicals that would be a 4 on the health rating. Arsenic would be another one. So now that we've gone over those, let's look at MSDS sheets, or material safety data sheets. We have a binder in the lab that's basically full of a data sheet for every chemical that we have in our storeroom. And it basically tells us all the information that we would need to know to keep you safe from this chemical, if it was on your skin, or if it was ingested, or if it was inhaled, or anything like that. So there's all kinds of different information on an MSDS sheet. A couple things you'll see: the identity of the material, the hazardous ingredients, if it causes cancer, or chemical and physical hazards, is it flammable, is it corrosive, okay? All those things would be on an MSDS sheet. You'd also see health hazards, like if it's acute or chronic. An acute health hazard would be something that would be dangerous immediately, like arsenic. A chronic health hazard would be something that builds up in your system over a period of time. Lead and water would be an example of this. Limits of exposure, where it enters, organs that it affects, emergency and first aid, all of these are things that would be found on an MSDS sheet. So this is an MSDS sheet. You can see there's a lot of information. Your responsibility for MSDS sheets is just to be able to read through them and find different types of health and hazardous information. Here's another example of an MSDS sheet. All right, so here is copper and nitric acid. These are the NFPA Fire Diamonds for them. Notice how they are different. Copper is not very flammable, is not reactive at all, and it has a very low health hazard. Okay, and notice it has no special hazard. So copper is a pretty safe material. You can hold copper in your hand and you're probably okay. All right, nitric acid, it's not flammable or reactive, but notice that it's a strong oxidizer and it has a high health hazard. So NFPA Fire Diamonds are really handy because you can glance at them very quickly and get a lot of information about how dangerous it is and how reactive it is. MSDS sheets are much more complicated and require more reading, but they also have more information. So they both have their pros and cons, and they're both beneficial to any chemist. So that's it for safety. Good job today. Let me know if you have any questions. We will see you next